Hi friends, this is my YouTube channel Vector Mathematics, and this is my first video what you are watching today. And this first video on a question that is uh, that I thought of, and this question is exclusively helpful for the students in class 9. And the question is, how can we measure the inertia of a body which is at rest or in motion? How can we measure the inertia of a body which is at rest or in motion? So I'll take two examples for the understanding purpose of this question. So first object that I'm going to take is a famous car name that know, we all know, that is the Ferrari. We all know the car Ferrari, and for me, for my own opinion, I think that this car is the fastest car that I've ever seen. So this Ferrari, and uh, the next object that I'm going to take is that object. Also, we all know that an airplane is the second object that I'm going to take. It is an airplane. So we have two objects here: Ferrari and an airplane. So listen carefully that I took the following informations from Google about a Ferrari. That is, in the case of Ferrari, my handwriting might not be too good, but because I'm writing in a virtual board, so you have to manage. Okay, whatever. If you don't understand anything, you can write in the comment box. My first point of purpose is on Ferrari. I got that Ferrari, the this car has a mass of an ordinary Ferrari car has a mass of 1500 kg, and here kg is the SI unit for mass. Okay, so we have the mass of a Ferrari that is equal to 1500 kg. Okay, second point that I have is, suppose I have the Ferrari present, I have the Ferrari and the airplane present in an airport. So we know about runway. So we think that there is a Ferrari next, I mean beside a airplane. So suppose the Ferrari starts, and the Ferrari the it's and it's starts from rest. That means 0 km per hour. Here km per hour is the speed. If the speed, okay, and it starts from 0 km per hour to 150 km per hour. Okay, so it starts from 0 km per hour to 150 km per hour speed. Okay, suppose if it changes speed from 0 km per hour to 150 km per hour speed, and the time taken to change the speed from rest is, we are taking the time as t equals to 50 seconds for the purpose of the thing. That is the time to change the Ferrari in 50 seconds. It changes speed from 0 to 150 km per hour. Okay, now the question is of the aeroplane that I earlier mentioned, that for the airplane I need to write write slowly because the handwriting gets worse and worse. Okay, so the aeroplane and mass of airplane is much more bigger than the Ferrari, and its mass is nearly 50,000 kilogram of an ordinary commercial airplane. So 50,000 kilometer, that is equal to 50 tons, because 1 ton equals to 1000 kg. 50 tons. So we have mass of airplane, let it be ma. Here a is not like a is not multiplying with m, but we are mentioning the mass of airplane by ma, as a system of notation. So mass of airplane is 50,000 kg, and mass of Ferrari we earlier mentioned mf equals to 1500 kg. Okay, we have two mass of two objects, and one mass, that is mass of airplane, is much more bigger than the mass of Ferrari. Now suppose the aeroplane changes its speed from 0 to 50 km per hour, 50 km per hour, from 0 speed to 50 km per hour in, and we saw in the case of the Ferrari, it changes its speed from 0 to 150 km per hour from within 50 seconds. But here we write of the, in the case of the airplane, it changes its speed from 0 to 50 km per hour in, let the time be, for the purpose, let's say that the airplane within 30 seconds. Okay, within 30 seconds. So the question now, let you just remember the time, that for the time of Ferrari it was 50 seconds, and the time of airplane is 30 seconds. Now let's think that I said that the Ferrari and the airplane both were side by side. Suppose this is the airplane. The drawing might be very funny, but for the timing purpose, I am not a professional artist, so the let this be the airplane in a runway. Suppose this is the runway, and we have a Ferrari present on the runway. Here it is, airplane is also standing on the runway. We have both the things together. Let me change the color of the Ferrari. Let me change it to red. Okay, the red color is the Ferrari. Okay, the top view of the Ferrari, that is standing the runway. Okay, so this Ferrari, okay, let me change the color to white. Okay, so okay, let's take the color of uh, blue for the notation purpose. Here it is the airplane, and here it is the Ferrari. Okay, so we got two things here, an airplane and a Ferrari. If both the airplane and the Ferrari to started suppose this airplane also started its engine, and Ferrari also starts its engine, so both are moving, and the speed of airplane was 50 km per hour, and that means the speed of airplane SA, we write it, and speed of the Ferrari SF equals to 150 kilometer per hour. Okay, as we mentioned earlier. And now it took the the airplane took how much time? 30 seconds. And the Ferrari took how much time? 50 seconds. So we have to find the acceleration, that is the change in speed with respect to change in time, change in speed, or you can say change in velocity, to be more appropriate. Acceleration is the change in velocity, and it's a vector quantity, which I will discuss later. That is a vector quantity, has a magnitude and a direction. So it's a change in velocity with respect to change in time. So where the velocity is a an unit which has both magnitude and also direction, that means velocity is also a vector quantity. So here we have the speed as, which is the magnitude is, I'm talking about the case of aeroplane. Let me draw aeroplane. Aeroplane. For the case of aeroplane, we have the acceleration, we have the we have the magnitude of the velocity as 50 kilometer per hour in the direction as straight line, and the time I, s- I, s- I gave time as 30 seconds. Now we have to write 30 seconds to kilometer to hour, I mean second to hour, because we are dealing with SI units. So 30 seconds to hour, it will be 30 by 6 seconds, because 6 seconds is 1 hour. So I get 1 by 2. So we will write the place of time, it's 1 by 2, and it's kilometer per hour, and this is uh, hour, time is hour. So 50 by 1 by 2, that means we get the acceleration of airplane equals to, acceleration of airplane equals to 100 into 2, I mean sorry, 50 into 2, that means 100, that's the 100 km per hour square. Okay, now we let us note that the acceleration of the aeroplane we got as 100 kilometer per hour square. Okay, now in the case of, let me change the color to, in the case of the Ferrari, we have, case of the Ferrari, we have the we had the acceleration equals to, acceleration of the Ferrari equals to, same thing, change in velocity by change in time, that is, it's a vector quantity. So velocity is, we mentioned earlier, was 150, and the time was 60 seconds. So 60 second, if we write 60 by 60 second, as, sorry, 50 seconds, earlier we mentioned it's 50 seconds, so we get 5 by 6 into second to hour. We changed it because we are dealing with SI units. So we got the time as 5 by 6 hour, and this is kilometer per hour. Okay, there's not enough space to write. Okay, so 150 by 5 by 6, that means 150 into 6 by 5, that means 30 here, and 30 into 6 equals to 180 km per hour square. So 180 kilometer per hour. Now we got the we got two things, that acceleration of the airplane equals to 100 km per hour, and the acceleration of the what called the Ferrari is 180 kilometer hour square. Here it is hour square. Acceleration of the Ferrari is 180 kilometer per hour square. So two accelerations. Now let us find the force that uh, force according to Newton's second law of motion. The force of the acceleration will be its mass times its acceleration. That is F is equal to ma. The mass of the Ferrari was 1500 into its acceleration, that is 180, and by multiplying 1500 we get 1,70,000 Newton. It's the unit for force in SI. 1,70,000 Newton for the Ferrari. I mean for the Ferrari FF, and for the force of the aeroplane, here it is same, the mass time acceleration. That is we have the airplane's mass as 50,000 into we got the acceleration as 100, so it becomes the acceleration of the airplane becomes, I mean the sorry the force of the airplane becomes, this is the force, that means the 5 lakh Newton, the 5 lakh Newton for the force that the airplane is moving with 5 lakh Newton. And in the case of the airplane we got it as 2,70,000 Newton. So we clearly see that force by the airplane is greater than the force of the Ferrari. So if we want to stop this object, we need more force. It clearly means that we need more force to stop the airplane than to stop the Ferrari. So we get that the Ferrari has less inertia. Here inertia means its tendency to stay in its state of motion. So we clearly see that Ferrari has less inertia than the airplane. Now the explanation for this is the mass of the Ferrari was smaller than mass of the airplane. So mass is the, although the Ferrari's velocity was much more faster than the airplane, but velocity depends nothing in the case of depends nothing in the case of inertia. So mass is the thing that tells about the seriousness of the inertia, whether the object is at rest or in motion. So we clearly get a result that now it's the result time, not the result of our exam but result of our video. The main purpose of the video was that result is mass is the measure of mass is the measure of an object's inertia. So don't think about velocity, acceleration, nothing except mass. This is the thing of this is the question of our answer. I mean, it's reciprocal. That is answer of question. Mass is the thing that tells of the measurement of the inertia. So mass is the measure of inertia of an object and nothing else. So thank you for the video. So hope better luck next. Hope you enjoy the video and better luck for the next time. Thank you.